Go.
Hi, I'm Paris and today I'm going to show you my artifact. I have made a house living room. Alright, this assessment is aimed for stage 3 students, potentially just year 6, with modifications to year 5. So this assessment is appropriate for stage 3 students as they're able to build appropriate artifacts with required materials. So this does require maturity from the students. This does align with the syllabus as well, as I'll show you the syllabus points. This model was selected to create as it draws interest from everyday life, such as for individual students in relation to their homes, giving them the ability to imagine, create and construct using their experiences throughout their learning process. Alright, this artifact meets all of the required elements of light, sound and movement. I've done this through a parallel and series circuit. So the lights, so I have 2 lights, they work in parallel on a series circuit. I have all 3 circuits in parallel, the motor which is made into a fan, and the lights and the buzzer work in a parallel circuit, and the switch is evident on each circuit, so there are 3 collecting all together. Alright, with my demonstration. So I will show you my demonstration. Up the top we have our 3 switches. I have my buzzer, my fan, and my lights. They all work all together, collecting the same amount of energy. Now, I can show you up close the light bulbs. If they are turned anti-clockwise, both lights will turn off. Once they are turned back clockwise, so both lights will turn back on. Through that demonstration, I'm able to highlight that all switches are turned on, all 3 components are working together with equal power to all 3 of them from the one power source. The lights turn on, fan will spin, and the buzzer will ring. All maintain the same energy from one power source, which is a 6-volt battery. All components can work individually, maintaining the same energy. The lights are in series with one another and is also working in parallel. In the demonstration, if one light is turned anti-clockwise, both lights will turn off. If the light is turned clockwise, then both lights will turn back on. Relating to my scientific concepts. For students to understand the key concepts and structure of this artifact, mathematics are requiring trial and error based on the voltage of the battery, singular power source required to flow all working circuits. Ways to communicate this through visual learning is the use of diagrams. By supplying all students with a physical diagram can give the students the ability to gain knowledge of positioning and structure of how to correctly put together a parallel and series circuit. In the classroom environment, I would provide each student with a diagram, which I've just drawn up here, which will be the same that I'm replicating on the board. By doing so, kids can have a visual representation of how this will be shown in the classroom and how they can make this individually as well. In relation to the primary connections resources, WordWall would be also sufficient for this. A WordWall allows students to support science and literacy experiences through reading, viewing, writing and speaking. Provide a visual representation to help students see patterns in words and decode them. Develop a growing bank of words that students can spell and read. Provide an ongoing support for various levels of academic ability in the classroom and teach the strategy of using word sources as a real life strategy. WordWall is great for modifying for students who maybe EALD as well, to help them decode the word and maybe put a definition as well. The words that I would start with as well would be battery, circuit, parallel, series, circuit. They'll be underlined on one source together, as well as switches and the other equipment required for this assessment. Okay, this is my circuit diagram. As shown, and the same for the individual diagram for the students, all are required to have the 6-volt battery with power reaching equally to each circuit. I have working in series, I have the 2 light bulbs as well as a switch. Working in parallel, I do have the switch and the motor, and the switch and the buzzer. So this links to science and technology syllabus for stage 3 students, as this model enables students to learn connections and investigate of creating parallel and series circuits simultaneously, conducting loops using wires, switches, 6-volt battery, light bulbs, motor and buzzer. By creating simultaneous loops as visible on the diagram, will allow students to visualize the difference of continuous circuit and parallel circuits. It is visible to also connect to sustainability strands as required as recycled materials were incorporated in the interior and exterior of this artefact. Therefore, students can link their own experiences when creating through the 5E processes of this assessment. The outcomes relate to the physical world. So the students will plan and use materials, tools, and equipment to develop solutions, explain how energy is transformed from one form to another, investigate the effects of increasing and decreasing the strength of specific contact and non-contact forces, and plan and conducts scientific investigations to answer testable questions and collects and summarizes data to communicate conclusions, therefore relating to the inquiry-based learning process of the 5Es. The indicators that this relates to is accurately cut, join, bend, and measure a range of selected materials to construct the design solution, demonstrate safety and sustainability when choosing resources to produce designed solutions, managing constraints and optimizing opportunities, and develop project plans that consider resources when producing design solutions individually and collaboratively. Alright, my general capabilities. This artifact relates through the 5E framework. By doing so, this empowers creative thinking. The capability of critical and creative thinking gives students the tools to examine the world around them, analyze their findings, and reach conclusions using evidence. Students are provided with the opportunity to harness a rich knowledge of each subject and apply their critical and creative thinking skills in a way that is specific to the subject. The 5E framework does allow this, as students are able to plan and then construct through the process to then lead to a final product. The science and technology syllabus encourages students to develop, acknowledge, and take into consideration environmental, social, cultural, and economic systems. Students develop knowledge regarding management of natural resources, as teachers need to provide students the right tools to enhance their learning from classroom to the real world. The New South Wales Education Standards suggest that actions that support more sustained patterns of living require students to participate critically and actively in determining more sustainable ways of living. This is displayed through the sustainable pedagogies, through the 3 Rs, reduce, reuse, and recycle, where were used throughout the assignment. So we have related to sustainability. Reduce, reuse, and recycled items I've listed here. We have used a cardboard box used in the construction, build, and exterior of the artefact. The interior decoration created from the same cardboard box, so the details inside we have from a street ice cream box. A paddle pop stick for the fan. And reduce, no waste by allowing students to play with the artefact in the classroom as a reward, and displays an exit slip activity through gallery walk. Reuse paddle pop stick and the ice cream box. And recycled cardboard is recycled into the exterior and interior of the house. This relates to 2 other KLAs. Firstly, we have geography, factors that shape environments. This relates strongly to the geography KLA, as it explains interactions and connections between people, places, and environments. Compare and contrast influences on the management of places and environments. Students are able to compare and contrast with their fellow peers about the resources they've used, what their house may look like, or how they would like it to be perceived. Creative arts makes artwork for different audiences, assembling materials in a variety of ways. Students can customize their artifact utilizing different items they have found at home and utilize their individual characteristics to make their artifact relevant to them. Trial and error. So firstly, when I was constructing this, we did try firstly with a 3-volt battery. However, there was complications running the 3-volt battery to equally sustain all three circuits. The complication was that all 3 circuits weren't running equally, so therefore the buzzer was not working and the lights had a dim. So what did we do? We did change it to a 6-volt battery. While testing that, we were able to see that it all sustained the same amount of energy. This can be replicated in the classroom, this artifact can be replicated in the classroom as it's purposeful of prioritising engaging activities within a classroom environment. This enables students to develop inquiry minds about science and their revolving world. However, challenges can be faced, such as getting frustrated, the amount of students skipping ahead of direction, and sharing the building process. How does this artifact align with the inquiry-based learning approach? Adopting an inquiry-based learning approach will engage students by making real-world connections through exploration and high-level questioning, venturing through the 5E model. Encouraging active planning and the process to build such artifacts allows students to investigate, research, and problem solve to find out how to make all three conducting loops work simultaneously. Breaking the lesson down, dividing occasion for the construction, for each component to be completed with solo, with group, and given time for the teacher to demonstrate will influence how and why to connect the elements, as students will be able to gain that knowledge. The breakdown of costs. Following the Scientific Views website, I did purchase both the JCAR Kit 1 and JCAR Kit 2, reaching almost $10 each. So it was almost, my total came up to almost $20. As I was able to find some stuff at home for the reduce, reuse and recycle element of this assessment, which is the fan using the paddle pop stick and the interior using the ice cream box pictures, as well as the interior using the remaining. Thank you for watching. I've included my references from Primary Connections as well as the NESA standards. Thank you for watching. Yay.